Good day, guys. We continue with integration by parts for maths and 6. So that remains our formula, and we use that abbreviation to make our choices for inverse, logarithm, algebra, trigonometry, exponential. So our first target here is integrating x to the power 5 multiplied by x over 5. So as we all know, for me to know that I make integration by part, if I differentiate x to the power 5, I can never get ln, I differentiate ln, I can never get x to the power 5. So that immediately takes me to integration by part, but I also need to know what kind of functions are here to give me the action. So x to the power 5 is obviously algebra, just as you see here. Algebra has x at the base, then ln falls under log, and if you check there, that is log, and in inlet, log is coming before algebra. So whatever comes first takes the position of f. So that means with our integration, we have to say let f of x this time be log, and I would prefer to call this 1 over 5x. So once it's like that, I need the derivative. So the derivative of log 1 over 5x means I'll take 1 divided by, when you're differentiating ln, you take 1 on the number there. You see the number there is 1 over 5x, so I'll take 1 divided by 1 over 5x, then I'll multiply that by the derivative of 1 over 5x. So if I differentiate 1 over 5x, it will give me 1 over 5. So that's it. Then 1 over 5, you take care of 1 over 5, and your answer reduces to 1 over x. So that's why the derivative of ln is most of the time leading us to 1 over x. Then we move now to g prime. So g prime is x to the power 5. That means if we integrate to get to g, we will have x to the power 6 over 6, which is the same thing as 1 over 6, x to the power 6. So we can now substitute into our formula. So if we now get to our formula, then the integral of x to the power 5 multiplied by ln 1 over 5x dx becomes, I take my f and my g, so that's my g and my f, that will give me 1 on 6 x to the power 6, then ln of 1 over 5x, then minus the integral of f prime g. So this is your f prime, that is your g. Usually when I'm taking them into my integral sign, I try to simplify them elsewhere first. So I've got x to the power 6 on 6 as my g, then my f prime is 1 over x. So if you look at it, you see that the constant that goes out is 1 over 6. So our constant out is 1 over 6, and we're left with x to the power 6 divided by x, which reduces to x to the power 5. So you can see very well that it's no longer a product. So just one simple step we are done. So if I integrate this, I'll get 1 over 6, x to the power 6, the ln of 1 over 5x minus 1 over 6 into, when you integrate this, you get 1 over 6, x to the power 6 again, plus c. So if you now simplify that, you will get your 1 over 6, x to the power 6, the ln of 1 over 5x, then multiplying out this gives us negative 1 on 36, x to the power 6 plus. So that's how simple it is to do that. Okay, so guys, we are done with this one. You can see it's pretty simple. So now we need to tackle the next. We're now integrating ln x over 3 all that square. So just like we saw arcsine, arctan, arcot, the inverse functions, when you also see the log functions standing alone, you must remember that it's integration by part. So to make it a product to accommodate integration by part, you simply multiply it by 1. And we know that each time we multiply by 1, that 1 is treated as algebra. So it means here we've got algebra and we've got log. And when you look at your inlet, in your inlet, log keep coming before algebra. So because log comes before algebra, it means your f must be log. So say let our f of x be equal to the limit of, I will now call it 1/3 x, all that square. So if that is my f, then its derivative, to differentiate this, I have to use the chain rule. The chain rule means I differentiate the outside first, where the number goes in front. So I'll write a 2, then I capture the inside and subtract 1 from the power. So if I subtract 1 from 2, it becomes 1. Then now I get inside. When I get inside, I now differentiate limit. Each time you differentiate limit, it gives you 1 divided by the number in front of limit, which is 1/3x. Then I multiply that by the derivative of that number. If I take the derivative of 1/3x, it gives me 1/3. So that is it. Here, 1/3 take care of 1/3. So I'm left with 2 lim 1/3x, all this divided by x. So that's my f prime. Then I can go to my g. If I say that g prime is equal to 1, from integration, g will be equal to x. So I can therefore get back to my integral, the integral of lim of 1/3x, all this square dx. What does it give me? I need my f and g. This is my f, and this is my g. So that will give me x, the lim of 1/3x, all this square, minus the integral of f prime g. Our f prime, we've simplified it until it looks like that. Then this is our g. So let me just capture them here. My f prime is 2 lim 1/3x on x. My g is x dx. So putting it like this, x will take care of itself. So that what we are left with is x, the lim of 1/3x, all that square, minus 2. Using 2 is a constant, so it can go out. So again, the lim of 1/3x. So now to integrate 1/3x to x, this one for Math N6 students, you don't even need to bother yourself with integration by part any longer because it's on page 2 of our formula sheet. So I'll just look at page 2 of my Math N6 formula sheet. I studied the integral, then I copy my answer from there. So on page number 2, the integral of lim ax gives me x lim ax minus x, where my a is 1/3. So on page number 2 for Math N6 students, this is simply what I'll be writing. Minus 2 in bracket to integrate lim ax. My formula sheet says I must write x lim ax. My x is 1/3, then minus x, then plus c, and I'm done. So if I have energy to open the bracket, that is fine. If you don't have that energy, you can still as well leave it like that. So I'm having the lim of 1/3x, all this square, minus 2x, the lim of 1/3x, then plus, you see this negative 2 and negative x will end up giving us 2x plus. So guys, that's the end of our story for integrating derivative logs. Thank you very much.